Hello.
Hi, and welcome you all to the second session for the day. So, moving on to our second session under the Python 4 web track, based on the theme Gradual Typing and Django, conducted by our second speaker, Kracekumar. So, for me to introduce our guest speaker for this session, Kracekumar is a software engineer based in Bangalore and interested in building reliable systems. He has interests in software engineering, data engineering, and FOS. He has given talks in several Python conferences like PyCon India, PyGotham, EuroPython, and etc. So, without further ado, let me invite Chris Kumar to the spotlight. And also make sure participants, by the end of this session conducted by our speaker, you all can direct your questions directly to him by the raise hand option, which will I be mentioning at the end as well. And also you can direct it through the Q&A segment. So the platform is all yours to conduct the session, Chris Kumar.
Hello, everyone. Welcome to my talk, Gradual Typing in Django. Who am I? I'm a software engineer. I'm Kracekumar. I'm a software engineer based out of Bangalore. I've been building backend systems for almost a decade right now. So the topic of this talk is Gradual Typing and Django. The talk is divided into 4 sections. In the first section, I will explain what is Gradual Typing and show some examples of gradual typed code and how to execute the code. And the second part, I will show how to actually introduce gradual typing in your Django source code. In the third part, I will help you share some of the tools, how you can add gradual typing to your existing code base or a new project from zero coverage to some significant coverage. In fourth part, so you'll have some closing thoughts on gradual typing and when you should use gradual typing, how do you measure the usefulness of gradual typing. So Python is a dynamically typed language, and it has been like that for past 25 years. Recently, what has happened is uh, with Python 3.5, the concept of type hints was introduced. And this Python type hints is still optional part of the language. That means like you can write a perfectly valid code without annotating your source code and it could work through. And these type hints are only introduced in version 3.5 onwards, and it's an optional part. And these type hints are not checked during Python runtime. It is only checked during static type checker time. Right. How does a gradually typed Python code look? Right. So here is a simple example where you have a class called a label. It is a Django model, and you have some name associated with the label, and you have a default ID. Right. And you have two functions of the same name: fetch from label table, and second one also from the same name. The difference between the first code and the second code is the first code there are no type hints. You can see like it takes in an argument and returns a list of some objects. In second code, what you could see is like there is a type annotation, right? So type annotation is the way of representing the data types which flow in through the program. Here the data flows in via this name parameter. So the annotation syntax is name, code, and string, and the return type is going to be a list of label. So that is why it has an arrow mark and saying the return type of this function is list of label. Now, how do you type check your program? Right now, you added the type hints to your program, and I told it's an optional part. That means when you run Python, your file name, this type hints are not checked, right? To do that, there is an official type checker. Its name is mypy. So you install this mypy as a third-party plugin. Pip install mypy, and what you do is mypy filename.py. So what it will do, it will see where all the code is type checked, and it will give some warnings or errors saying like, hey, this type information does not adhere to what you have declared, what the function returns. So it gives some useful information about all of these data. So types at runtime, right? Even though Python is a dynamically typed language, there is implicit types associated with a variable. Let's say you create a variable called name and assign it a value string hello. In the next line, you can say name is equal to 23. Still, Python will not complain. But there are behind the scenes, there are types associated with each variable or the data flow. So how do you know what is a type of a variable or a type of a statement or whatever return value of a function? So there is an inbuilt library called inbuilt function called type. So if you pass a data to it, it will return the what is the type of the data or a placeholder. Right? Here we are using say type of I pass like a tuple. First argument is a string, second argument is an integer. It returns the type as a tuple. In the second example, you can see when I pass a Django user object filter result, it returns it as query.query set, right? So you can see the type information is still we are able to infer at the runtime. So static checker type, right? So this type hints at when you run a Python interpreter, it interprets types of these variables and data flow in a different way. The static type checker will interpret the types in a different way. Let's see the same example using a static type checker. So when you run a program using mypy filename.py, you have this function reveal type, which is visible to the program, which is similar to the type function. So for example, here when I use a reveal type, and what reveal type reveals the type of the tuple is, it says tuple of string comma int. Basically, it is saying it is a tuple type. Outer type is tuple, but inner elements, the first element is of type string, second element is of the type integer. Let's try the same example for the Django code. When you pass the similar output to the output of the user object to the reveal type function, it's slightly different. It does not say query set. It says a query manager of user. This is a slightly specific details of Django, which we'll see it in the later part. But the important takeaway from this comparison is the type function at runtime only looks at the top type, but whereas at the static type checker will go as much as deep it is possible because it needs to know the type of each and every placeholder or a data inside a container data type. So mypy has got a configuration. So important reason why we have to look into this section is by default, a lot of third-party libraries support type hints. Some of the libraries does not support type hints. One such example is Django. So Django source code does not contain any type annotations for the existing source code. So in order to make type hints work with Django, there is a third-party library called Django stubs. And we need to tell mypy like there is a plugin called mypy Django plugin. Whenever you run this mypy file name or the project name, and what will mypy do? Mypy will, whenever the Django is invoked, it will look into this particular plugin, mypy Django plugin for all the type annotation. And second part, every Django project has got a Django settings. This setting is absolutely required by the mypy or the Django stubs to know how to import what are installed apps. For that, you need to specify the configuration. Where is your settings file? That goes under mypy.plugins.django stubs. These two configuration is required to make sure that your project will work with mypy. So next part is annotating the Django actual code. So Django, roughly, everybody knows Django follows this pattern of model, template, view pattern. Model is where you declare all your database related details. Views where you actually handle HTTP requests, and templates is where you actually handle the rendering logic. But in a modern single page application, what happens is you have a set of views and return a JSON response, and JSON response is either is a serialized data, or you can use something like data class to serialize. So in general, like the T part, I will not cover in this section. I only cover the model and the view part. So here's a simple Django function-based view. So Django function index function takes a request and returns a response. And here the annotation is very straightforward. The HTTP module has got the classes. So request belongs to HTTP request. I'm annotating it as request code and HTTP request, and the response is HTTP response. Right. The same kind of concept will work in Django REST framework or Django class-based views. You don't need to annotate the self what to say attribute, but you need to annotate the other parameters in the method call, right? Here is a slightly modified function of the index function. Here we have a function view 404. It returns a HTTP response not found. But interesting aspect here is like you can annotate the return type of the same function in 3 different ways, right? First example, you see the return type is mentioned as HTTP response. In the second function, it is annotated as HTTP response not found. In the third part, it is annotated as an object, right? But actually, what we are returning is HTTP response not found. And mypy type checker is not complaining on all of these 3 definitions, right? We need to know why this happens and why this behavior is good. So there is an important concept called method resolution order. If you return any class, you know there is an order of hierarchy where a parent class, child class relation comes in. When you call a constructor of that or initializer or any method and a child class, there is an order in which all the parent class get executed. That is a super call, right? So similarly, there is some the type checker also uses this method resolution order. Let's say on every class you have this method called MRO, you can invoke it. For example, if you invoke HTTP response.mro, it says in the order in which these classes are inherited. The bottom one is the parent class, and all the one above are the child classes. For example, in this, HTTP response inherits HTTP response base, which internally inherits objects. Right? If you see HTTP response not found, HTTP response not found inherits HTTP response. HTTP response inherits HTTP response base and then object. For all practical purpose, you can consider a child class to be a special class of a parent class, and any of these particular classes in the hierarchy can be replaced. Right? And that's a very specific name for this principle. It is called Liskov substitution principle. What Liskov substitution principle states is in an object-oriented program, substituting a superclass object with an object of any of its subclasses, the program should not break. Right? This is a very good way to design. For example, you're selling an event system. You can have different types of event system, like a customer event or an internal event. Still, that event class can be used, and the entire flow can be similar. Right? This particular concept will come useful whenever you are annotating any of the class-based code in Python. So next is Django models. In Django model section, we'll see like how to create a Django model, how to annotate that particular function, then read part, and then there's some filter part. So for example, here we have a simple model with 2 explicit fields. One explicit, the model name is question, it inherits models.model. And on the first field is question text of character field. Next is pub date of datetime field. There's an implicit field ID. Right? Let's say we want to create a utility function called create question. The type annotation is like it takes in a string and it creates a question. So it returns the instance which is just created. So you can see when we mention only the class name, it is understood that we are returning instance of that particular class. So this is very simple. When you are passing an instance of a Django model, you just have to mention the name of the class. So next is the read part. So we have a simple function called get question. Right, the get question takes in a string question text and return a question. You see the implementation detail question.objects.filter method we are using, and whenever there's a first match, we are returning that particular result. When you run this piece of code against mypy error says like incompatible return value, got optional of any expected question. So this is a little bit of the implementation detail you should know about Django. So when you invoke a dot first method, it may return a none or the instance, right? That is basically what this error message is saying. It is optional of any. Optional means none, any means any instance. In our case, it is saying question, right? Basically, what can happen is when you pass in a question text which is not found in the database, you return a none value. But our type annotation says that return value will be of instance question, which is what causing a trouble for the mypy type checker. Now, how do we address this particular feedback from the type checker? So there are 2 ways to address. First is you explicitly say that optional of questions. So when you say optional of questions, the optional is a proxy for none type. You have to import it from typing module, import optional. Right? Now, what will happen is now mypy understands that get question function can return none value or an instance of question. This is one way to address the error message given by mypy. And the next method is modifying the mypy config. Like previously, we saw we can configure plugins and other details that are required for these libraries to work. There is a configuration we can specify mypy to behave it in certain manner. Strict underscore optional is equal to false. Basically, what we are saying is like even when a return type is none, if a source code does not explicitly say optional, do not throw any error. This is very good starting point when your project does not have any of the type hints, right? Because a lot of time none values will be coming from your functions and methods. So to start, when you have 0% type hints, it start with strict underscore optional is equal to false. When you have a decent amount of coverage and you want to increase the strictness, and you can actually make this value to true. For all practical purpose, you can consider it to be a knob from how strict your type checker should be, whether it to be too strict or it should be a too lenient or strict, right? These kind of options help you to tweak the configuration to get the desired output for your project. So next is the filter method. So Django objects, that is like a Django manager has got these objects which you have where there are a lot of methods. For example, like if you do question.objects.all, returns all the rows in that particular table. And if you see the result, right, if you see the REPR representation of the result, it says query set of question 1, question 2. Basically, there is an outer type called query set, and there's an inner values or questions. Similarly, if you do question.objects.filter, you would see similar kind of representation printed in the terminal. Now, how do you annotate? So before getting into the annotation, you have to understand this query set. The query set is a very important concept in Django where entire data goes in and whenever you're reading data from the database, most of the methods return a query set. Query, for all practical purpose, you would consider a query set to be a box type, where the outer type is the query set. Inner values can be anything. It can be query set of question. It can be a query set of user. So whenever we're annotating, we have to mention whether it's a query set and also what is the type which query set will carry. So here are two functions where you have filter question, exclude question. So filter question takes in a string and uses a filter method and returns a query set of questions, right? Here this query set can be an empty or query set can contain lot of values, right? So that is why you're saying query set of questions. The second is exclude questions. You say dot exclude, and then you do some filter on top of the table, and you return the result. The returning result. How do you annotate? Query set of question. Whenever the result type is query set, you have to specify its query set. What is the value it will carry? So methods returning query. There are a few other methods like Django model managers which will return some of the query set values. For example, some are all reverse, distinct, or order by union. So either a method on the Django model will return an instance or it will return a query set, right? And most of the time it will return the query set and you need to annotate properly. Next is the tools part, right? So let's say like you already have a source code where been in production for 2 years. Right now, we want to add the type hints to the code. It is going to be a humongous task, right? And that initial pressure to add, it will take very long time. After that, only you can see all of the benefits, right? But there are some tools where which can with 0% type hints, it can, if you do some kind of runs, it can give you a lot of information about the types, and then you can add those details into the source code, which will help you to get a decent type coverage. So one such tool I would say is PyAnnotate. So PyAnnotate is a tool developed at Dropbox. So what it does is automatically insert type hints into the code. Like how does it do, right? While running a test case, you can use this plugin called PyTest Annotate. So I'm understanding most of the people at some point have to have test case in their projects. Once you have test case and you have decent test coverages, then you will be able to get a lot of type hints from that data, right? So once you add this PyTest Annotate in the PyTest runner, then what it will do is, like, when you execute the PyTest, it can infer the types which are passed during this function test, right? When you assert a method, what is the value it is returning? When you call the function, what parameters are it passed? What are its types, right? So it can infer all of these data, and it can store it in a text file, and then you will be able to apply it the later phase, right? Let's see a simple example how to do that. So here is a simple Django code. We have two functions, index and view 404. It takes in a request and returns two different types of response. As you can see, there are no type hints available for this particular piece of code. Now, the first step is you have a source code. The second step is you need test file. Here is a simple test code where you are testing that business logic. We are using a request factory. It creates a request and then it sends a response. And here we are not asserting the response, but in general, you will be asserting a value at the end of a test case. Right? Now, we have these two test cases for this particular piece of code. Now, what do we do next? So while running this test case, we need to actually pass in an extra value called annotate output, and we need to specify the location to store this info types. Right here, we are saying store all the info types in this file called annotations.json file. Now, after running this test case, you will see this annotations.json file. It will have some list of dictionaries or JSON values. So what you will see here is, like, each individual object here is like it will specify one code block. For example, let's see the first example, first value, path poll/views.py file. Second is what is the line number, what is the function name, what is the type comments, right? So it says like that input parameter is django.code.handles.whiskey request, and the output type is django.http response.http response. You see the second example, the first two lines are same, third one different function name, input argument type is same. We come to the output, it says exactly the HTTP response not found. Right. Now, that's one detail is an implementation detail. When you run Django test, you don't actually send a proper HTTP request, use a whiskey request. Because of that drawback, the tool is unable to understand it's a HTTP request. That is why it is saying it is a whiskey request. This is one of the limitations of the tool. Once you have this annotation file, now what do you need to do? Now you need to apply these annotations, right? Now, how do you do that? I'm using poetry as an example to show, but the actual command is pyannotate type info. You can say where is the location of the type details, and the next is like which file are you referring, and what is the syntax type, right? Since the tool was developed long ago, it supports both Python 2 and Python 3. In our case, we want the syntax to be Python 3. That is why we are passing a flag -py3. How does the modified file look? Now, if you look into the modified file, this is the file which has got overridden by pyannotate file. It has got the type annotation in the functions. You can see request is whiskey request, response is HTTP response, HTTP response not found. Another aspect, it also figures out how to do imports properly. It adds the imports in the top of the file. You can see both HTTP response and response not found imported, but you can see like HTTP response and HTTP response not found, right? That was not properly imported. I think like this is something you can use another tool like iSort, and it will be able to figure out how to properly sort this imports, all of it. So in general, this tool is really a good place, good tool where you can get some decent coverage for the project which has got no type coverage at all. So you can start with this tool and you will get something, you can save initial time, and then you can start annotating manually as part of your code review process or part of feature requests. Right. Now, next section is how do you learn about type hints? Because type hints is a new concept in Python, and it's very hard to find. There are no books. I don't think so. There are any books, but there are a lot of videos. There are a lot of talks from a lot of companies, right? So one of the tool which I developed here, it is called Python typing chaos. So chaos means a riddle. So the concept is like you have a lot of files in this project. You go to GitHub and you clone it. Each file, either the type annotation is already available or it is missing. And if it is available, it may be wrong. So as a learner, what you do, you run mypy, the file name .py. Here is an example you run, and it will say like these are the errors in this particular file. Now, as a learner, what you do is you will figure out what is this error in this particular line, and you go look up into the documentation and figure out how I can solve these errors. There are comments in the code. It will say like what is this error, how you can fix it. Now, once you understand it and you try to change the type annotations or add the missing type annotation and run the mypy type checker. When the errors are zero, it means that there are no type errors. By that way, while solving all of these broken code, you will get an understanding how this type hints work, right? And at the end, the idea is if you solve set of some 20 problems, you'll get a very decent understanding how to annotate a Python code. That is the idea of this project. Now, always the thorny part is like, should my new project use gradual typing or not? So if you see in a lot of Twitter, there is like a two camps says like with gradual typing, Python is no more a Python. There's another camp which says like there are a lot of advantages with gradual typing. So that's also said by Davis Beasley that even that type hints are optional in Python language, but it is enforced by the Python community, right? So now, how do you decide whether you should use the gradual typing or not? So my answer to that question is like it is not now. The question is when you should use type hints. At this point, for me, it is very clear. Type hints is something you will need it at a different point of your Python project, because a Python project which is started on day one will not be same as day 1000. And during this 1000 days, if you're a startup, the code evolves a lot of things are changing. So it may not be the right time to add at the beginning of the project type hints, because you will lose a lot of that the fast development with Python. So in my view, there is something called as developer productivity. In developer productivity rank, I would say like tests are very important for any project. Second is linting, formatter, test coverages, and definitely documentation, CI/CD, static analysis like SimGrep tool. And finally, when you know that your project is stable and it is going to live for a very long time, then I would suggest you to add type hints. Without knowing this future of the project, adding type hints may not be really useful, because the problem is how do you justify its usefulness versus the time it takes to annotate a project with type hints. So this is my view. So once you have decent test coverage, good documentation, you set up CI/CD, then it makes sense to add type hints. Of course, the exception being that if your only objective of the project is learn how to use type hints, then you will definitely start from day one. But if you're building a library which is really at the hacking stage, then I would not suggest using type hints. Right? Some closing thoughts. There is always a problem. How do you measure the gains by using type hints, right? So this is really a hard question. We don't have any tools to say that whether how much did we gain by adding type hints. For example, like if you're using type hints and if you're wrongly annotated the code and tests are not covering it, type hints may catch the bug before even it goes to production. But you cannot justify in some sort of a tool to measure it, right? At some place you consider to be like a closed system where before adding type hints there are so many errors. After coming adding type hints, there are so many errors. So does it reduced? Or all of those things are anecdotal evidences. We don't have very large scale studies, at least in Python, which clearly says the advantages of using type hints. That is the what is the difficulty of the problem as well. And in case you have any questions, I'm happy to answer. And you can follow me on Twitter or Chris the King. This is my GitHub handle. I'm happy to answer your questions. Thank you. Right. I think I have a question. What if we want to return different types of return values according to a condition? Is there any way we can use for the purpose? I mean, something like or for a return type, right? Yes, I have not covered that particular use case because I don't want to complicate the talk. So there is a union type in Python where, for example, if your return type can be a string or a Unicode, let's say you're going to return get or create user, right? In that case, or let's say you want to return integer or a float. So your return type can be union of int, comma, float. That means the return type will be either either integer or a float. So those things are possible in Python. So the next question I have is like, can we use mypy modules with test case writing? Right. So I think like example which I showed, PyTest annotate, I think that can be some sort of an answer to this question. So which can infer types, but I'm not sure like I understood the question correctly. If you're understanding, like let's say you're building a typing module, can you write test cases? I think it is possible to do that, but I have not done myself. But if you look into some other libraries like Django stubs, how do they write test cases for the library? I think you may be able to get the answer for this question. Right. Next question is, what are the databases that can be worked with Django? Yeah. For example, Django has got drivers for most of the databases like Postgres, MySQL, all the SQL data types you will be able to see in their official documentation. But there are some other, libraries, like let's say you wanted to use DynamoDB or Cassandra, you will find libraries for it. But I'm not sure how well it goes with Django, because Django user object only designed for a SQL relational database. So you may have to tweak in the library and certain functionality work. But in general, I have found like Django supports a lot of databases, and drivers are available in Python package index. There are few questions here. Is Django opinionated or not? And I don't think so. It is as opinionated like other frameworks. But I would not like to mention what other frameworks I mean. But in general, I find Django edition to be much more mature and stable. And I'm using Django for like almost like 8-9 years for different projects. I've been happy with it. They've been constantly innovating and making sure like the experience is great. I would.
Yes.
I would
Are you okay with going on with a few more questions since we have time?
Right. I'm happy to take a few more questions. Yes.
Yeah. So if there's anyone, you all can as well use the raise hand option and direct your questions directly to Kracekumar, other than the Q&A session. So yeah.
I think there are a few more questions in the chat. I think like we can cover that and come to that if that is fine.
Yeah, sure. All right.
I will skip the question like what are the firms using Django. I think that should be like you can go to the docs, and when, for example, Instagram uses Django, there will be a lot of sites. That's a very easy question. There are some more interesting questions I would like to answer. How would PyAnnotate handle mock classes or model factories in test? Yes, so that will be definitely be a limitation, right? Here, like what would happen is like it will return the mock unit test.mock as a return type, and that is something limitation you have to manually replace it. I'm not sure whether I have handled that particular use case, right? The next question is like, does this tool report type coverage? Yes, definitely, right? So mypy has got an option for this coverage. When you mention like mypy, when you run mypy, you can actually say like hyphen coverage where to store it. It will returns the coverage, and this coverage is slightly different coverage. What does this coverage cover is, it will mention like which is the file name, what is the precise level of coverage information does this file have. For example, if you don't annotate a variable, the default type for that variable will be any, right? If you say name colon any is equal to Crace, if you say name colon str is equal to Crace, the second one is far more precise type compared to the previous one. So mypy will consider that to be a precise type. Now, while producing the coverage report, MyPy will say like which lines has got imprecise type definition. That is more like the tests which does not cover those particular lines. So this tool, I am using it in production, and it has been quite useful. For example, I always look into the coverage and see whether which lines does not have proper type coverage. We try to increase the type coverage. That is definitely a useful tool. and it comes as part of mypy. Next thing, is there best practices to handle type hints for KWR? So this is a really important question. So initial versions of Python did not have very good support for KWRs, but recent version of Python 3.9, I think they have introduced something called parent spec, where you can actually mention these kind of KWRs and star arcs, and also for decorators, and you can use that param spec. It's a type from how we are doing from typing import union. There are some kind of a ways to annotate KWRs. It is still at the very early phase, but you would be able to do if you use param spec and other kind of type hints which are evolving right now. Right. I think if there are any other folks who would like to ask questions, yeah, they can please go ahead.
Yes, you can use the raise hand option and direct your questions to Kracekumar.
I think there are no questions, I guess, and there was like a very handful of questions we received in the Q&A section.
Yes. So in that case, as we see, there were questions in the Q&A segment, and Kracekumar almost answered everything. I hope you all got a good insight on that as well. And since none of our participants have raised their hands to directly ask any questions from Kracekumar, I think we can end our session as well. And yes. So yeah, we can see a raise of hand from Indika Rajapaksha. I think you can unmute yourself and direct your question to Kracekumar.
Hear me?
Yes.
I want to ask, when we use this gradual typing, is there a recommendation we should not use it for small projects, or there is a requirement that certain number of developers should be there, because this is somewhat normally we don't do at Django developing, right?
Oh, right. So the question, if I understood correctly, is there any recommended a place when we should use this type hints in the project? Is that your question? And when we are not supposed to use, correct?
Yes.
Right. As I said in the beginning, the type hints is not a mandatory in the Python code. It is an optional part first. Second is lot of projects decide not to use this type. For example, Django's official source code does not have any type annotation in their repository. They are saying we will not use it. Right? That gives us a clear signal they feel is more complex in their project to use. But there are third-party libraries which helps what to say Django stubs to incorporate these type hints in your Django projects. And like I said in the earlier part, right, it is also always there is a new feature available, and it also you need to give some value for it. There are two aspects, right? What is the cost associated with using this type hints? What is the value you get out of using this type hints, right? So as I said earlier, if your project is a prototype phase, I would not say no. I would definitely say do not use type hints, because it is going to take a lot of your time and you won't be delivered in time. For an example, on the other hand, if the project is mature and there are a lot of developers, when I say a lot of developers, it can be different. It can be a mono repo, or it can be a micro repo, whatever pattern you are using, right? And you need to have a lot of people who will come in and leave the source code, or you will be using the source code to do it, right? Once you know your project itself is a stable project and it is going to continue for quite some time, say for next 2 years, 3 years, so just a number I'm saying. But in general, you know this long term, this project is going to survive. And adding type hints will benefit the users in terms of catching bugs in place of using it to reduce the cognitive load, all of those reasons. That is one. And the next part is like you will be always using some dependencies, right? You should also consider whether all the dependencies support type hints or not. For example, if you're using a library that does not support type hints, then what would happen is in your entire code flow, those parts you cannot type annotate, right? That is going to be a difficult thing for you in a long run. So it is what to say, like conscious call as a project lead or whoever is owning the project to figure out when is the right time to add type hints to your project and how much can you get benefit out of those type hints. Did that answer your question?
Definitely. Definitely. Thank you.
Welcome.
All right. Thank you so much, Indika, for that question for Kracekumar. And thank you, Kracekumar, for answering that question. So with that, we've come to the end of our second session along with Kracekumar, who brought out a very insightful session with a lot of information. So yes, and our heartiest gratitude to you, Kracekumar, for sparing your time with us and giving out a lot of inputs with regard to Django and all. And I hope every delegate got a good knowledge about it. So thank you so much. And also, thank you so much for all the participants who participated with us for the second session. So before moving on to the lunch break, I had to make a couple of announcements from our side. So next up, we have arranged a networking space for you from 12:30 p.m. to 1 p.m. till the next session for you to get the experience of meeting each other in a physical conference. So here you would be able to randomly get paired with another delegate for a 5-minute conversation to share your contacts and ideas within the time. And you can also continue matching with another partner until 1 p.m. to share your knowledge and thoughts and also to gather new Python enthusiasts to your circle. And also a small reminder that you can join the booths of Matific Sri Lanka and Isaac to have a discussion with them and enjoy the interactive sessions by standing a chance to win exclusive gifts at the booths as well. Also, a kind reminder to reserve your delicate pack with a t-shirt to wear with pride as an enthusiastic member of the Python community. The links for reservations are posted in your delegate groups, so please make sure you reserve the pack as soon as possible before the stocks are over. So with that, once again, I thank Kracekumar and also thank you for all the participants. Thank you and see you by 1 p.m. for the next session.